Okay, so we are doing absences and final grades, and we're doing regression. We're going to start with the descriptives information. So these formulas kind of assume that you already have the mean and the standard deviation. Could you get them using the formulas from like chapter 3 or 4? Yeah, you could. It's nice that we have the information though. So the first thing we're going to find is the slope. So we need the standard deviation for variable y. So remember that it's going to be final grade and number of absences was the x. So the standard deviation is going to be this number, 16.8 divided by 4.38 times this correlation, which we found previously, and it was negative 0.94. So this piece is just 3.83 times negative 0.94, so it's going to be negative. There's a relationship between, let me put here, slope and the correlation, so the symbol will stay the same, negative 3.6. The next thing we're going to do is find the y-intercept. So for that, we're going to need the mean of y and the mean of x, and they're right there in our descriptives information. So B0, it's going to be 73 minus what we just found, negative 3.6 times x bar, which is 8.14. So we're going to do this piece first. 73 minus, it is going to be negative 29.3. Put B0 here, B0. Move this up a little bit. So it's going to be 73 plus 29.3, which is like 102.3. It kind of goes over what realistically what a grade would be. Let's do the regression equation next. So for the regression equation, we need y hat, and that's going to be 102. So this is the intercept, minus 3.6, and it's usually x, but you can also write it like this, absences, because in this case, I'm just going to put abs, because in this case, x is representing the variable absences. You can also write it like this, final grade, and then you can have like the little hat. And I actually like this one because it makes, more sense in the context of the problem. Because what we have to do next is make a prediction. When a person has 10 absences, what would be the final predicted grade? Or if I just use FG for final grade. So the little hat tells us that it's predicted. That's why we put it in there. So 102.3 minus 3.6. And then instead of absences, I'm going to put the value that we're interested in, which is 10. So final grades, there you go. That should be like 66.3. This is the answer. So now we're going to look at the output. So we have one table that's called model fit measures, and this R is the same as our correlation. Note that Jamovi doesn't really print the, if this was negative, it would not have a negative here. It kind of does the absolute value. So you still have to go through the correlation menu to get that. Then it has the R square. So there's one way of finding that, which is 0.944. We would square that and it would give us 0.892. And this would be our R square, which is the variance explained. So I have variable y, which is my final grade. And then I have variable x, which is absences. So that's how much absences explains of the final grade, which is 89%. Like the highest could be like 100. That's a lot. It's explaining a lot. And then if we're doing like multiple regression, we would have like multiple variables, maybe GPA, other things that you could add to this. Just not right now. over here we're going to have the intercept. So that's exactly what we, well, I think ours was rounded, was like 0.3, but it's pretty close. So normally we don't, in the table, we don't focus a lot in the intercept. What we focus on is the number of absences. Why the number of absences? Because it's the actual predictor that we're interested in. It's the x. So this is our x, and this is the information that we're going to present for beta. And this is our p-value, but we kind of knew that just at this point of the class. So for beta, I mentioned because we're going to need it here. And then the p-value, we're going to need it here. And then the r-squared, let me change my color, we're going to need it here. So how do we write our correlation, our regression conclusion? Well, we say we did a simpler linear regressions. There's different types, so that's why it's important to say. We gave the alpha. We kind of mentioned like what we're trying to predict. So here it's my independent variable. And it was statistically significant. How do I know it was statistically significant? From the p-value, I compare it to alpha 0.05 or whatever I gave you in the problem. And it is smaller, so it is statistically significant. Of the dependent variable, this is the dependent variable, and then you give me the beta. So this can be a little bit confusing because we have B0, B1. This beta is just how APA style wants you to write it. So it's going to refer to this. And then you put that value, which I show you, the p-value. Then you're going to talk about the r-squared. So the r-squared is the value that you have in the table. And then I usually ask you for a prediction. In this case, I ask for a prediction for 10 absences. So if a person has 10 absences, the predicted grade is that value.